Hello and welcome back. In this video I want to explain how to minimize disturbances during the refilling of the feeder hopper. Let's look again at the feeding process. You can see that we have to refill the feeder at regular intervals for a continuous process. Here you see a diagram of the mass flow signal from the balance over time. This is unfiltered process data from a feeder. The refill results in a strong fluctuation of the signal. This signal is used to control the mass flow rate of the feeder. Therefore, any disruption of this signal disrupts the process control significantly. If the balance is still used for mass flow control, this can cause counterproductive changes in the screw speed, which result in significant mass flow deviations. Remember, in the last video, we also discussed the volumetric operation mode. For longer run times, this is not accurate, but for short time intervals, it is still quite reliable. This is only half of the problem, as also the density of the powder and the degree of filling of the screw changes during the refill. Still, this is a valid option. So if we know that we are about to refill the feeder, we switch the feeder from gravimetric to volumetric mode. And once the refill is finished, we switch back. Here you see the screw speed of a feeder. The gray areas are in gravimetric mode and the red areas are the ones during refill, which are in volumetric mode. There are different options for choosing the screw speed in volumetric mode. The first straightforward approach is leaving the speed at the last verified level. This has the disadvantage that as you refill the feeder, the pressure on the powder on the bottom increases again. So does the density and consequently the mass flow increases, which you can see here. Another option is to set the screw speed to the average between the maximum speed just before the refill and the minimum right after the refill. Feeding tests must be carried out before processing to enable this control approach. This approach will likely give a good result, as you see here. There are also more sophisticated approaches. It is also possible to ramp down the screw speed as the filling progresses. This ramp down of the screw speed has to be verified with data. To do this, a feeding test must be carried out before the process to collect the relevant data for the screw speed and mass flow. This data can then be used to create a suitable model for the refill. If you change your refill scenario by changing the material, adjusting the minimum mass flow for the refill to start, or refill takes longer, the model needs to be adjusted to the new settings. Depending on the process and powder properties, each of the three scenarios can be a good fit for the process. If you buy a feeder, you will notice that each vendor has a different approach to solving this. But there is usually also the possibility of choosing your own approach. Please consider that depending on the material being fed, the behavior during refill can be pretty different. Less material per screw revolution may be conveyed than just before refill. Here in the group, we did many tests with different feeder types and operation modes. If you are interested in more details or want to implement continuous manufacturing technologies at your facility, get in touch with us. With that, I want to thank you for your attention. See you soon.